So we're going to look today at the graph. This is a video for 6.8. I'm going to look at the graph of first cosecant of x, which is the reciprocal of sine of x. And on these axes right now, drawn is sine of x. And remember what reciprocal means. It means the flip of the ratio. So let's go through some key points here on the sine graph to get an idea of what is happening with cosecant. So the reciprocal of 0, let's start on the origin, is undefined. So that, in fact, is going to be an asymptote here. And then the reciprocal of 1, which is the first peak here, is 1. And then the reciprocal of 0 is undefined, so we're going to have another asymptote here. But let's see what happens in between. Say I were to take something like this point here. Say it was 1/100th. What is the reciprocal of 1/100th? Well, it would be 100. So in fact, the closer I get to 0, the reciprocal of that is going to be towards infinity. So I've got a graph looking, well, that should be going through 1, looking like that. Okay, so let's, again, continuing this vein, the reciprocal of -1 is -1. And then reciprocal of 0 is undefined, so we're going to have that asymptote. Why the vertical asymptote? Well, the reciprocal, again, the reciprocal values as I get closer and closer to 0 are going to be huge. So remember, vertical asymptote occurs where a function, as the function is approaching that x value, the y value is exploding, either positively or negatively. So the graph is going to continue on like this. So I'll just draw a couple more. Draw some on the negative side here. So let's talk about what then we can say about the domain and range here. So we've got the domain. Well, it's all reals except these places where it's undefined, where the asymptotes are. So all reals except how often was sine 0? Because that's how often cosecant will be undefined. Well, that's every k pi. And the range, notice it's, instead of being between -1 and 1, it's the opposite of that. So the range will be -infinity to -1 inclusive, union 1 inclusive to infinity. So that is your cosecant graph. All right, let's now go to secant. Whoops. Okay, so here's a graph of cosine. And we're going to do a similar process here. And in fact, the graph, just like sine and cosine are a shift different from each other, the same is true of secant and cosecant. They look nearly identical. And in fact, every graph of one you can write as an equation in terms of either cosecant or secant, just like you could do with sine and cosine. Sorry, I'm sketching this pretty quickly. But hopefully you can get the idea. So now let's talk about the domain and range here. The domain is all reals except, well, the first time it's going to be undefined is pi/2. So except pi/2 plus k pi, because again, it gets undefined at 3pi/2 and so on. Whereas the range is the same as the range of cosecant. So -infinity to -1 inclusive, union 1 to infinity. Okay, so now let's check out this last other trig graph, the graph of cotangent. And remember, cotangent is equal to x over y. All right, so let's see what's happening here. So tangent of 0 was 0, but the reciprocal of that will be undefined. So I kind of like cotangent because it's very clean looking. It starts undefined, and then let's graph a few other points in between here. So I'm not only going to graph pi over 2, I also want to graph pi over 4 because that's a nice one to graph. Cotangent of pi over 4 is 1. And cotangent of pi over 2 is going to be 0. And then if we do 3 pi over 4, that'll be -1. And if we do pi, that will be 2 undefined. Because remember, on the x-axis, y is 0. All right. So what is this graph looking like? It is looking like this. Because remember, as I am really close to 0, let me draw it on, if I'm talking about the circle here. If my angle is super close to 0, my y value is very tiny comparative to my x value. So that is making it explode in a positive way. Whereas because in the second quadrant, when we're looking over here, the x value is negative, that's why it's going to be exploding in a negative way there. Okay, this continues on, so we could extend this. So if I were to do negative pi here, this would be negative pi over 2, and it has the same look. And so that's the graph of cotangent. Let's, like we did with all the others, state the domain. So the domain here is all reals except every k pi. But the range, like the range of tangent, is all real numbers. Okay, so those are the final 3 graphs.